In this lecture, we'll be covering another reaction. More specifically, we'll be covering the Fischer esterification of acetic acid with isoamyl alcohol. So this reaction involves creating isopentyl acetate. Isopentyl acetate is an ester, and it has this form, right? We have 1, 2, 3, 4, 5. We have our oxygen here, and then we have our carboxyl group here. And this is often referred to as banana oil, simply because this ester has a fragrance, and it is actually the smell of banana, right? So the Fischer esterification is actually an equilibrium reaction. The equilibrium is not very favorable for the formation of the ester, so Le Chatelier's principle is used in order to shift the reaction to the right in favor of the formation of the ester, which is our product. The way this is done is by using the excess of one of the starting materials, which is known as the mass action, right? And usually acetic acid is used in excess because it is less expensive than isopentyl alcohol. And also sulfuric acid is added to the reaction, which helps bind the H2O produced because it's very attracted to the water, right? So in order to isolate the product, it will need to be extracted using sodium bicarbonate and water in order to remove any of the excess acetic acid that wasn't used in the reaction. After the drying it with sodium sulfate anhydrous, the ester is purified by distillation, and the purity of the liquid can be analyzed by IR spectroscopy, right, to determine if you have your desired ester or not. So on this slide, you can see the mechanism of this esterification reaction. You have your acetic acid here, the carbonyl. It attacks the proton from the sulfuric acid, and you end up forming this equilibrium here, right, of the two resonance structures of the protonated acetic acid, which is the ion, oxonium ion, and the carbocation, right? And so you can have your alcohol right here, which is the isopentyl alcohol, and it attacks this carbon here, and it forms this other equilibrium in which they separate and they come back together. And so this equilibrium then shifts in this direction so that you have a protonated water molecule. This is then removed by the mechanism, and it forms this oxonium ion again, which is then removed. The proton is then removed, and you end up forming your final product. You'll notice here that all of these were equilibrium reactions, so this is why Le Chatelier's principle is needed in order to shift the reaction in the direction of this product formation right here. So here you can see another example of the mechanism, right? You see here the overall reaction up here. You have your isopentyl alcohol and your acetic acid, which gets protonated by sulfuric acid, and it forms your final product of the ester right here, plus water. So here you can see the mechanism, your protonated acetic acid. It has this resonance structure, right, with the formation of this carbocation. The alcohol then attacks the carbocation, and you can see right here the mechanism, right? Basically, it's exactly the same thing as the previous line. It just has the molecules drawn out, and you end up with your final product with the ester, right? And here you can see Le Chatelier's principle, right? How do you shift the reaction to go from left to right so that the equilibrium arrow is pointing more towards this way? Well, you can either add more of this or add more of this, right? Or in some cases, as we discussed previously, you can remove one of these two. In this case, the water was removed for one of the reactions we did in the past. So generally, if the ester is volatile, the best approach is to distill out the ester while the reaction is underway, or you can add an excess of the cheapest starting compound. In this activity, we added excess acetic acid as well as excess sulfuric acid. So why would sulfuric acid help to shift the reaction to the right? Well, it's a stronger acid that catalyzes the reaction and makes the reaction go faster because it's such a strong acid, right? And it also has a very strong attraction for water, which helps shift the reaction to the right by binding this water here, right? So you can see the reaction here. You have your sulfuric acid and your water, and it forms these ions here, right? So the equilibrium for this reaction is far to the right, helping to shift the equilibrium for the Fischer esterification to the right, right? So here's the difference between the textbook and the procedure that is being followed here in this lecture. In the textbook, they use butanol and 0.03 moles of 1-butanol, 0.09 moles of glacial acetic acid, and 3 times excess. For this procedure that we're following in this lecture, we're going to use isoamyl alcohol, 0.03 moles, the same amount, right, of isoamyl alcohol, which is about 2.64 grams, or 3.26 milliliters, and 0.09 moles of glacial acetic acid, which is, again, 3 times the excess. The only difference is the alcohol, right? You have here your isoamyl alcohol, and you have your butanol. Isoamyl alcohol is another name for isopentyl alcohol, right? You would generally follow the textbook, but in this case, you would use the amount of isoamyl alcohol specified right here. So this is basically how the procedure would be followed. You would have a 25 milliliter round bottom flask, and in this flask you would add 3.27 milliliters of your alcohol, 5.21 milliliters of glacial acetic acid. This means that it's a very strong acetic acid, right? It means very little water in it. You add your 0.4 milliliters of concentrated sulfuric acid. Very dangerous, right? So you would have to keep this in mind. And 3 boiling chips, as you always do when you're boiling things. And the next step would be to add water to the condenser to cool it, right? So water in here, water out to the top. And then you heat to a reflux, right? Reflux means that it'll boil and then it'll come back down through the condenser so that the reaction is constantly heating, right, without losing any of your solvent. One thing you want to keep in mind is you don't want to cover this. You don't want to have pressure build up and things blow up, and that's a problem, right? So you want to keep this open to the air. It's okay. None of this will actually come out because it'll cool down and drip back down into the reaction. One thing to note, again, as I mentioned earlier, glacial acetic acid and sulfuric acid are very dangerous, so you would have to handle them with great care, right? So always be careful with that. Another, again, always clamp everything tightly, right? Use a ring clamp to raise your heating mantle, just so that you can access it more quickly, right? You could either use a West condenser or a distillation column. Some things to keep in mind here with this experiment is one thing is weighing out small masses is usually a lot easier to do than measuring out small volumes. And of course, this is a very simple reason, right? You have a digital scale that gives you a lot of numbers, right? This is a lot more accurate than trying to see the little lines on a cylinder. So it would be preferable to weigh your sample, even if it's liquid. You would just grab your cylinder, tear it on the scale, and then add dropwise your isoamyl alcohol, right? Just try to make sure you get as close to the amount as you can. It might not always be possible to measure out the weight, so if you're using the volume, just be very careful. And as for measuring sulfuric acid, well, in reality, sulfuric acid is a catalyst, right? So the stoichiometry isn't so important as long as you're close to the desired value here, which is 0.4 milliliters, you should be fine. So you could actually measure it with just how many drops you used, right? So you would end up using around 8 drops of this acid. But as always, just be very careful because it's very corrosive. Once your reaction is done refluxing, you want to cool it down in an ice bath. One thing to be very careful with, though, is you don't want to put burning hot glass in cold water because that's a recipe for disaster, right? You can crack the glass and that's very dangerous. You have sulfuric acid in here and all that. So just wait until it's cool to the touch and then put it in the ice bath. The next step is to transfer your products, right? So you would take your round bottom flask, decant it from the boiling chips. You don't want to add the boiling chips into the separatory funnel, and you would add 5 milliliters of deionized water. So, and you would wash the round bottom flask with that water and decant the water into this reaction. You want to shake it gently because you might end up forming an emulsion, and that just means that there's bubbles of one liquid in the other, and sometimes that can take a very long time to go away, right? So you want to be careful with that. Allow the layers to form and remove the lower aqueous layer. And then go over technique for washing, right? So you would have to just wash it a few times, right? So this next step involves washing it with sodium carbonate solution. So you would swirl the funnel for several minutes and allow most of the CO2 to escape. And the way you do this is you flip it upside down, facing away from your face, and you open this valve here to let the CO2 out, right? The reason you don't want to keep opening this is because it has silicone grease, and that can end up being kind of a mess, right? So you want to open it from this part, but always point it upwards. Then you cap the funnel, you shake and allow the layers to form, and then you would remove the lower aqueous layer. And this is, of course, to remove your excess acetic acid, right? As we discussed earlier. The next step is to dry your product. So you want to transfer this onto a beaker, which has a small amount of magnesium sulfate. And the magnesium sulfate is going to suck the water out of the product, right? And then you would decant this liquid after a little bit into another flask. You want to use a filter paper to prevent any of the magnesium sulfate to pass into your product. One important thing to note here is you want to decant it, right? You don't want to add a big clump of magnesium sulfate in the filter because then you'll be there forever waiting for the liquid to pass through it. It can take a very long time if you have too much magnesium sulfate in the filter paper. So just be sure to just get the liquid out. You can also wash it with around 2 milliliters of pentane to get as much of your product out of the magnesium sulfate as possible, and then pass that through your filter. You can allow the drying agent to settle, right? So you would have to wait for everything to settle down before you decant it. You may have a small amount of product. You may want to use a test tube instead of a beaker for drying. That just depends, right? Pentane is extremely volatile, so volatility means that it evaporates very easily. So you want to close the bottle or flask right as soon as you're done. So next, the final step is the simple distillation. You would want to use a 25 milliliter round bottom flask, right? And the reason it's a simple distillation is you can see here, the boiling point of pentane is 36. It's very low, right? Very easy to boil. And the boiling point of isoamyl acetate is 142 Celsius, which is significantly higher, right? You will need 2 test tubes. The first one is to collect the low boiling pentane. This is not your product, so you can just throw it into the correct bin. And then the second test tube, you would want to pre-weigh it and then collect your isoamyl acetate. And you would check which is which by the temperature, right? And of course, as always before mentioned, do not distill to dryness, right? Because especially in this case, can be dangerous. So the dried solution goes into the round bottom flask, right? And you put 3 boiling chips here. You guys have seen this before, right? Distillation, you have your Kleisen condenser here, your thermometer to the adapter, and then your condenser with the water coming in from the bottom, going out through the top. And then the condenser would be on top of a test tube that everything would be clamped, right? Of course. And that concludes this lecture. If you have any questions, please don't hesitate to send me an email. Also, just remember all the safety rules. If you ever go back to the in-person learning, just remember that you always have to be very careful when handling any of these chemicals, right? And always dispose of everything properly.